So in this particular video, we are going to build a clone of the cp command in Linux. So this is the start of a new series where I build clones of a lot of existing Linux CLI tools like cp, ls, so on and so forth. So right now, we are going to build a clone of the cp command. So if you're not aware of the cp command, it's basically a simple command to copy files and directories. Just say cp and the file you want to copy, and the next is the destination. So we can just say new test.txt. So a copy of the original test.txt file has been made. So now I can cat both these files, and you can see that the command has been successfully copied, or the file has been successfully copied. So we're going to build something similar, a clone of the cp tool. So now let's implement the copy tool. So I'm going to call it copy.c. I've created a file, copy.c, and we are going to require the stdio library, and then just declare the main function. We are going to take in some commands as command line arguments. Sorry, some parameters as command line arguments. So for example, here, the source file and destination file, we need them as user input. So we have to take them as command line arguments. So I'll just say int argc and char star star argv. So we are accepting command line arguments. So now these are the steps that we have to follow to implement this particular program. So first of all, we have to open the source and the destination files, and then we copy the contents of the source file into the memory, and then we copy it from the memory into the destination file. We can't really directly copy between the source and destination. We can't directly do that. We have to copy the source into the memory and get it from the memory into the destination folder, and then we just close all those files. So to do that, you actually open the source and the destination file. That's our first step. But before that, let's actually make sure that we are receiving enough arguments. So we have to actually get at least three arguments, including the file name, source file, and the destination file. And if it's not three arguments, we are going to just say, and we'll just say return one. So we'll break the program if enough arguments are not provided. And after that, we have to actually open the source file and the destination file. We'll just say file and source is equal to, we'll use the fopen function. If you're not aware of the fopen function, take a look at the man page. Basically, it can help us create, we can open files, and it will return us a pointer to the file stream. And yeah, fopen, it takes two arguments. It takes the path name and the mode. Yeah, it takes the path name of the file and the mode. And if you remember, we are actually getting three arguments in total, including the file name, source file, and destination file. So the source file is supposed to go here. So just going to say it's the first argument, and the mode is going to be R. We're going to read the file, and we're going to do some error handling here. If source is equal to null, or if the file doesn't exist, or if the file is empty, we just are going to say it's an error. Now we do the same thing with the destination file. You can just copy the entire thing, paste it here. So we change it to destination, and this is going to be the second argument, and we have to actually open this in write mode, because yeah, we have to write into this file, so it's different. And we change everything here. So yeah, that's all we have to do. So we have opened the source file, destination file, and we have a pointer access to the file stream. So that's done. So the first step is over. We open the source and the destination file. Now we have to copy the contents of the source file into the memory. So first of all, we have to allocate some memory space to actually copy the contents. So first of all, let's allocate some memory spaces, create a buffer, and we need to actually specify the buffer size here, or the memory size that we want to allocate. So let's actually define something for that. But before that, let's just say it's buffer size. And now we have to declare what buffer size is. Let's do that on the top using the define keyword. Define buffer size. Let's just say 4096 bytes. We need to declare another argument of size t called bytes read. And if you don't really know what size t is, it's actually kind of like integer, but just positive numbers. So yeah, it's an unsigned integer that type that can assign only 0 and greater than 0. Basically, only positive numbers are allowed. So if you say int, it could have negative numbers. So we are avoiding that issue by declaring it size t. And yeah, bytes read. All right, so now we actually have to read the contents of the file and transfer it to the buffer. So we have to copy the contents of the source file into the buffer. So we can do that using the freads function. So if you're not aware of the freads function, you can always take a look at the manual pages for freads. So we have to supply in 4 arguments here. We'll just say fread. First of all, we have to supply in the buffer, and then the individual size of data you have to read. So we're going to read this byte by byte using 1 here, and then this is like the total size. We're going to supply the buffer size here, and finally the file stream, which is the source file. Now this will allow us to read about 4096 bytes of data from the source file. So that is what this statement is doing. But we actually have to read the entire file, not just a particular amount of bytes. We actually don't know what the exact size of the file is. So we have to read the file until it's empty. So we have to read the entire file. So how will we do that? So we'll just say while, and inside a while loop, we'll actually check. We'll just say bytes read is equal to fread of buffer1 buffer size source is greater than 0. So we'll use this while loop to read this entire file and transfer it to the buffer. So that's how it works. And now the entire file will be read regardless of the file size. And finally, we just have to write the contents into the destination file from the buffer. So now we have to transfer it from the buffer into the destination. So this line, we have done the first step, which is to copy the contents of the source into the memory. So that's accomplished here. Now the next step is to copy the contents of the memory from the memory back into the destination file. All right. So to do that, we'll just say fwrite, and fwrite also has 4 arguments: the buffer size, the total size, and the file stream. So we'll just say buffer, then 1 will read it byte by byte, and this is like the total size, which is going to be bytes read. And finally, the file stream that we want to write this to, which is the destination file. All right, so that is done. Now finally, close all the files. Fclose source and fclose the destination. It's done. We can add a return 0 here because this is some end function, so you may encounter some warnings otherwise. So it's over. Now to compile this program, you can actually use GCC or Clang, which I prefer. Output is copy.c. Here we have a few errors. All right, I misspelled print. Printf as print. I've been using Python for a while, so that's the error. So I've compiled it successfully. Now let's execute it. So copy, and then I'll just say test.text and new copy.text. So that's the copy we are going to create. So the new copy file. So let's cat new copy cat test.text. And yes, it has work successfully. And if you supply in an argument, or if you supply in a file, for example, that doesn't exist, you'll get error messages, error opening files. You can add some formatting here if you want. All right, everyone. So that's it with this video. So I'll meet you in the next one with a similar project. Bye bye.